Good morning, students. In the previous video, we discussed about condition for the line y equal to mx plus c. Condition for the line y equal to mx plus c to be a tangent. To the parabola y squared equal to 4ax. We derived the condition for this. Condition for the line y equal to mx plus c to be a tangent to the parabola y squared equal to 4ax. Already we derived. The required condition from this is c equal to a by m. In the previous video we discussed the concept. Then we are able to substitute instead of this c. Then we can get this equation becomes y equal to mx plus a by m. This is also said to be the equation of the tangent to the parabola y squared equal to 4ax. Before that we already discussed two types of tangent, two tangents. What are the two types? Equation of the tangent at the x1 comma y1. At the x1 comma y1 equation of the tangent we derived. Then again instead of at x1 comma y1 at t. At t we already derived. The t means at squared comma 2at. This is nothing but the parametric. So parametric equation. So we already worked out equation of the tangent at the x1 comma y1 and equation of the tangent at t. T means at squared comma 2at. Here you are using the word at. At means this point must be on the parabola. Therefore here you are using equation of the tangent at x1 comma y1. Another one equation of the tangent at t. Here we are using y equal to mx plus a by m is also the equation of the tangent to the parabola in terms of slope, where m is said to be slope. Here where m is slope. So in terms of slope, if you want to find out the equation of the tangent, we must use this. At x1 comma y1 we are using the equation of the tangent is y1 is equal to 2a x plus x1. We already worked out. So this is at t. Instead of x1 comma y1 we can substitute the point at square comma 2at. Then we can get equation of the tangent at t. That means yt equal to x plus at squared. This is also equation of the tangent. This is also equation of the tangent. This is also equation of the tangent. Here we are. You must know what is the difference between these two. Here you are using the word at x1 comma y1. Here you are using the word at t. Here there is no point at x1 comma y1. Here there is no meaningless. Here y equal to mx plus a by m. This is also the equation of the tangent where m is the slope. So we are already discussing about this concept. Today we are going to work out equation of the tangent at the x1 comma y1 to the ellipse. See, what is the general equation of an ellipse? Not the full derivation, just a concept which we are able to work out. General equation of the ellipse. What is the general equation of the ellipse? X squared by a squared plus y squared by b squared equal to 1. This is the equation of the general equation of the ellipse. Now we want to find equation of the tangent. Equation of the tangent at x1 comma y1. So equation of the tangent at x1 comma y1. We are having a short procedure. This x squared is replaced by xx1 by a squared plus this y squared is replaced by y1 by b squared equal to 1. So we are able to get the simplest procedure to find the equation of the tangent. So general equation of the ellipse x squared by a squared plus y squared by b squared equal to 1. We want to find the equation of the tangent at x1 comma y1. Just to replace x squared is replaced by xx1 by a squared, y squared is replaced by y1 by b squared equal to 1. You are taking this equation of the tangent. But in your working out the equation of the tangent to the parabola, we worked out all the derivation part. What are the derivation part? First we worked out the equation of the chord, then the chord becomes tangent. Here we are selecting direct procedures. X squared is replaced by xx1, y squared is equal to replaced by yy1, then divided by a squared divided by b squared as it is. This is the equation of the tangent. Now, for what purpose we are selecting this one? Now, we are going to derive the condition for the line y equal to mx plus c to be a tangent to the ellipse now. That is also an important derivation. Take down this heading. Condition for the line. Condition for the line y equal to mx plus c. Y equal to mx plus c to be a tangent. Yesterday we discussed about to be a tangent to the parabola. Now to be a tangent to the ellipse. To be a tangent to the ellipse. X squared by a squared plus y squared by b squared equal to 1. So today we are going to derive the same type of condition. Condition for the line y equal to mx plus c to be a tangent to the ellipse. Yesterday we discussed it to be a tangent to the parabola. Today we are going to discuss two derivation. One is for the ellipse, another one is for the hyperbola. Now listen, same procedure we discussed about yesterday itself, but procedure is same. Now, what is the general equation of an ellipse? Equation number 1. Equation of an ellipse. X squared by a squared plus y squared by b squared equal to 1. Say this is equation number 1. General equation of an ellipse. Then equation of the tangent. Equation of the tangent at the x1 comma y1. At the x1 comma y1. This is the equation of an ellipse. This is the equation of the tangent at the x1 comma y1. Just now we discussed x squared is replaced by xx1. So that I recall that concept. X squared is replaced by xx1. Y squared is replaced by yy1 divided by b squared equal to 1. Say this is equation of the tangent. Very simplest procedure. X squared must be replaced by xx1. Y squared is replaced by y1 divided by a squared divided by b squared as it is. This is said to be equation of the tangent at the x1 comma y1 to an ellipse. Now, what is the equation of the given line? Equation of the given line. Equation of the given line is y equal to mx plus c. I can rearrange this one. Mx minus y plus c equal to 0. Say it is equation number 3. In the same way, I can rearrange the equation number 2 also. So xx1 by a squared plus yy1 by b squared. I can take this minus 1 here equal to 0. Consider this is equation number 2. So just rearranging xx1 by a squared plus yy1 by b squared minus 1 equal to 0. That is the equation of the tangent. This is also equation of the straight line. This straight line becomes tangent. That is the required condition we are going to find out. Listen, compare 2 and 3. Both are same line. See x family, y family, constant. Here also x family, y family, constant. Therefore, equation 2 and 3 represents the same line. They are discussing about represents the same line. This is the equation of the tangent. This is the given line. This is also represent to be a tangent. Therefore, both equation 2 and 3 represents the same line. Therefore, the coefficients of x, y, constant term must be in proportional. That is the logic we are going to use. Listen carefully. Equation 2 and 3. See the sentences. Equation 2 and 3 represents the same line. Therefore, coefficient of x, coefficient of y, constant term of the equation 2 and 3 must be in proportional. So we are going to find out that proportional. See, what is the meaning of proportional? What is the coefficient of x here? x1 divided by a squared. That is the coefficient of x. x1 divided by a squared. Here what is the coefficient of x? divided by m, that is equal to, what is the coefficient of y? y1 divided by b squared. Here what is the coefficient of y? Divided by minus 1. That is equal to, what is the coefficient of constant? That means minus 1 constant here. Here what is the constant? C. So this is called proportionate. So coefficient of x, y constant term. Here coefficient of x, y constant term must be in proportional. So now we can simplify this one. x1 by a squared divided by m, I can write like this. x1 divided by a squared m, both are same only. Here I can write y1 divided by minus b squared. This must be minus 1 divided by c. So from this I am able to find out x1 and y1 because the point we need at x1 comma y1, so we need the point x1 comma y1. From this I can find out. Listen this one, comparing the first and last. That means equating first and last. What is the value here? x1 divided by a squared m equal to, I can write minus 1 by c. From this I need x1. So x1 equal to, cross multiplying this one, I can get minus a squared m divided by c. This is the value of x1. In the same way, from this, comparing these two, y1 divided by minus b squared equal to minus 1 divided by c. So cross multiplying this minus b squared, it will become positive. Therefore, y1 equal to b squared divided by c. y1 equal to b squared by c. So far, just listen this concept. Given ellipse, that means standard equation of an ellipse. Equation of the tangent at x1 comma y1, just x squared is replaced by xx1 by a squared, y squared is replaced by y1 by b squared equal to 1. I can rearrange this one, xx1 by a squared plus yy1 by b squared minus 1 equal to 0. This is the equation of the given line, y equal to mx plus c. Convert into the same side, mx minus y plus c equal to 0. Now this is the explanation you need. Equation 2 and 3 represents the same line. They are discussing about the tangents. Both the equation represents about the tangent. Therefore, equation 2 and 3 represents the same line. Therefore, coefficient of x and y and the constant term are in proportional. We want to find the proportion. Proportion is nothing but division. So, x1 by a squared divided by this coefficient m. Then y1 by b squared divided by this coefficient. What is the coefficient of y here? Minus 1. Then what are the constant term? Minus 1 is the constant. Here c is the constant. I can write like this. x1 divided by a squared m. y1 divided by minus b squared. Then minus 1 by c. I can equate first and last. See, I am equating first and last. I am able to find out x1. In the same way, equating second and third term. Second and third term. We can get the value of y1. Now x1 comma y1 we are able to find out now the point, because at the x1 comma y1 it is nothing but the point. Therefore the point p of x1 comma y1 equal to, now we are finding out this point p of x1 comma y1. What is the value? Minus a squared m divided by c, minus a squared m by c, comma, the value of y1 is b squared by c. This is called point of contact. The point of contact p x1 comma y1 is minus a squared m by c, b squared by c. You can say the point of contact also. The point of contact p of x1 comma y1 equal to minus a squared m by c, b squared by c. What is the use of this point? Now listen. The general equation of the hyperbola, the general equation of the, ellipse here, the general equation of the ellipse passing through p of x1 comma y1. The ellipse passing through the point p of x1 comma y1. What is the reason? We are discussing about the tangent at x1 comma y1. Generally, we can listen this one. What is the meaning of the tangent? Is said to be an ellipse. See here, consider a point here. So this is said to be tangent. At means P of x1 comma y1. So the tangent contact at P of x1 comma y1. Therefore this ellipse must passing through the point P of x1 comma y1. Now the ellipse passing through the point P of x1 comma y1, that means this is said to be point of contact. Now the equation of the ellipse, what is the equation? We are selecting just now x squared by a squared plus y squared by b squared equal to 1. Instead of this x squared, it must be replaced by x1 squared by a squared plus y1 squared by b squared equal to 1. So this is the general equation of an ellipse. Point of contact means P of x1 comma y1. That means this is the tangent. This tangent at P of x1 comma y1 means this ellipse also passing through the point. This equation must be converted like this: x1 squared by a squared plus y1 squared by b squared equal to 1. So for this only we already find out the value of x1 comma y1. Just we are able to substitute. See, what is the value of x1 squared here? Minus a squared m divided by c the whole square, because x1 squared is x1, minus a squared m by c the whole square divided by a squared, plus what is the value of y1? B squared divided by c the whole square divided by b squared equal to 1. Isn't this concept? In the previous explanation we discussed about the point of contact P of x1 comma y1 minus a squared m by c b squared by c. Again, just write this explanation: the ellipse passing through the point P of x1 comma y1. See this diagram, you can analyze. This is the equation of an ellipse, diagrammatic explanation. Just draw a rough diagram. Then this is the equation of the tangent. Contact with the P x1 comma, that is called at means point of contact with the ellipse and the tangent. Therefore this ellipse passing through the point, this equation becomes x1 squared by a squared plus y1 squared by b squared equal to 1. Now we are able to simplify, then we are able to get the condition. Now listen this one. Instead of x1, y1, we are substituting. Just squaring this value, negative will become positive. A power 4 m squared divided by c squared. Already we are denominator, we are having a squared plus here b squared by c squared, b power 4, already b squared, again b power 4 divided by c squared. In the denominator we are having b squared equal to 1. This a squared and a power 4 will be removed. We can get a squared m squared divided by c squared plus here b squared and b power 4 will be removed. B squared by c squared equal to 1. I can take this c squared as the common value. The remaining a squared m squared plus b squared equal to 1. Just to cross multiplying this one. Therefore c squared equal to a squared m squared plus b squared is the required condition for the line y equal to mx plus c to be a tangent to an ellipse. This is the required condition. From this we can say c equal to plus or minus square root of a squared m squared plus b squared. C equal to plus or minus root of a squared m squared plus b squared is the required condition. Again, once again listen. We are able to simplify this one. X1 squared, y1 squared, already you find out. Instead of this x1, y1, just substitute the value. This becomes a power 4, m power 2 divided by c squared, already having the denominator a squared. Here b power 4 divided by c squared, already you are having the denominator b squared. This must be simplified. A squared m squared by c squared. Here b squared divided by c squared. Consider c squared as a common value. Then cross multiply. We can get c squared equal to a squared m squared plus b squared is the required condition. From this we can say c equal to plus or minus square root of a squared m squared plus b squared. From this we are able to conclude. This is the required condition for the line y equal to mx plus c to be a tangent to an ellipse. In the same way, dear students, you have to try one more result from this. Then what is the second one? This is the first condition, c squared equal to a squared m squared plus b squared. From this, we can say y equal to mx. Initially we are saying plus c. That is the condition we just did. Hereafter we can say instead of this c, y equal to mx plus c, instead of this c, what is the value we are hearing? Y equal to mx plus or minus square root of a squared m squared plus b squared is also the equation of the tangent. So instead of c, I am substituting the value c equal to plus or minus square root of a squared m squared plus b squared. From this, again listen, we can write like this, y equal to mx plus square root of a squared m squared plus b squared, or y equal to mx minus square root of a squared m squared plus b squared is the equation of the tangent. Here see, either this equation or this equation. Don't consider the both the equation, either y equal to mx plus square root of a squared m squared b squared. Here supposing writing the or means either this one or you can select this one, must be the equation of the tangent. Here also m is to be slope. So at x1 comma y1, at the parametric, that is the different. Here y equal to mx means where m is called slope. So this is the equation of this is the required condition. See, we can replace this value c. Therefore hereafter y equal to mx plus or minus square root of a squared plus m squared plus b squared is also the equation of the tangent. From this either plus or minus, this must be the equation of the tangent to an ellipse. This is the required condition. So today's homework, dear students, you try yourself. This is your work. Try yourself. What is the next one? Same one. Condition for the line y equal to mx plus c. I am giving the maximum explanation. That means your work is very simple one. Condition for the line. Condition for the line y equal to mx plus c to be a tangent. To be a tangent to the hyperbola, x squared by a squared minus y squared by b squared equal to 1. So this is your work. Try yourself. Compare with the ellipse. Very small difference, only one difference. In ellipse you are having the plus symbol, x squared by a squared plus y squared by b squared equal to 1. Here you are having negative symbol. That means the second family containing negative. All other steps are the same when comparing with the ellipse. See, what is the condition? Equation number 1. This is the given hyperbola. Say given hyperbola. Given hyperbola. X squared by a squared minus y squared by b squared equal to 1. Say this is equation number 1. Given hyperbola. Then equation of the tangent. Equation of the tangent at x1 comma y1. So equation of the tangent at x1 comma y1, very simple. X squared is replaced by xx1 by a squared minus yy1 by b squared equal to 1. Rearrange this one. We can get xx1 by a squared minus yy1 by b squared minus 1 equal to 0. Say this is equation number 2. Comparing with the ellipse, we are having only one small change here. Plus symbol means ellipse. Here we are having negative symbol. That is the only one difference. Then equation of the given line. What is the equation of the given line? That is nothing but given line y equal to mx plus c. So rearrange this one. We can get mx minus y plus c equal to 0. Say this is equation number 3. So compare with the the same one. Y equal to mx plus c. Convert into the same sign. We can get mx minus y plus c. Now already explained in the derivation of an ellipse. Equation 2 and 3 represents the same line. That means they are discussing about the tangent. Therefore, coefficient of x, y and the constant term are in proportional. you can write that explanation. See, coefficient of x. What is the coefficient of x here? x1 divided by a squared. Divided by, what is the coefficient of x? That is equal to m. Again, what is the coefficient of y here? Minus y1 divided by b squared divided by coefficient of y is minus 1. Then what is the constant term? Minus 1. Here what is the constant term? C. Same type of explanation and compare with the ellipse. Given ellipse, instead of this we are having plus. Then you are having plus symbol for an ellipse. You can already work out. Then come same one with the negative here. There you are having plus symbol. Then this is the same line, mx minus y plus c equal to 0. Then equation 2 and 3 represent the same line. Therefore, coefficient of x and the coefficient of y constant term are in proportional. Here you are having a negative symbol. There you are having the plus symbol. Then from this you are able to work out. From this you are able to work out. See this one, I can write like this. x1 by a squared m equal to a. Here both negative will be removed. That is the only one change. y1 divided by b squared. Here both the negative will be removed. Here see, negative will be removed. How? The coefficient of y must be y1 by b squared. Here also minus, it will be removed. Equal to minus 1 by c. Now we are able to compare this 1 and 3. From this see, x1 by a squared m equal to minus 1 by c. I need x1 from this. Therefore, x1 equal to cross multiplying minus a squared m divided by c. This is the value of x1. Compare with ellipse. The same. Compare this one. So from this, we are able to compare y1 by b squared equal to minus 1 by c. Comparing this second and last. From this, I can find the value of y1 minus b squared by c. When comparing with the ellipse, we are having a small difference. See your ellipse, you can get the positive symbol here. Here you can get the negative symbol. So x1 I already find out. Value of y1 already find out. Therefore point x1 comma y1. Point x1 comma y1 just we worked out. Minus a squared m by c comma minus b squared by c. So see your ellipse derivation. There you are getting positive. Here you are getting negative. That is the only one different. Now, what is the purpose of finding out x1 comma y1? Already we explained the hyperbola passing through the point P of x1 comma y1. See, what is the meaning of at? The point must be on the hyperbola. Therefore, the hyperbola passing through the point. What is the equation of the hyperbola? X squared by a squared minus y squared by b squared equal to 1. That hyperbola passing through the point P of x1 comma y1. Therefore, hyperbola equation can be modified as x1 squared by a squared minus y1 squared by b squared equal to 1. Your work is, you have to substitute this value x1 comma y1. I already worked out everything. Just a very simple 5% work only you have to do. Already worked out x1, y1. Up to point of contact, we are worked out. Your work, you try yourself. Hereafter, what is the concept? The hyperbola passing through the point P of x1 comma y1. You can draw a diagram, very simple diagram. Draw a hyperbola tangent at x1 comma y1. That means the hyperbola must passing through the point P of x1 comma y1. You have to eliminate x comma y instead of x1 comma y1. You can substitute. Therefore, the equation may be modified x1 squared by a squared minus y1 squared by b squared equal to 1. Dear student, after that, you have to substitute the value x1 comma y1, simplify, find the condition c squared equal to the same, compare with the same ellipse. What is the result? There we are getting c squared equal to a squared m squared plus b squared for an ellipse. Here you are able to derive c squared equal to a squared m squared minus b squared. Try yourself up to this work I have completed. So you derive yourself. Verify your book also. Now listen. What is the next derivation? So far we worked out three concepts. The same concept. That is condition for the line y equal to mx plus c to be a tangent. Organize all these. Condition for the line y equal to mx plus c to be a tangent to the parabola. That is the first derivation. From that we can conclude y equal to mx plus a by m is also the equation of the tangent where m is the slope. Then we are able to find out the point of contact x1 comma y1. Here today we discussed condition for the line y equal to mx plus c to be a tangent to an ellipse. Then the third one is condition for the line y equal to mx plus c to be a tangent to the hyperbola. So already we worked out all the concepts. Just your work, find the last result. C squared equal to a squared m squared minus b squared is the condition. You can try yourself, you are able to get. Then the next theoretical concept is two tangents. This is the next theoretical concept. Two tangents can be drawn. Two tangents can be drawn to the parabola, y squared equal to 4ax from any point. This is the next theoretical condition. Two tangents can be drawn to the parabola y squared equal to 4ax from any point. Now listen. Already we derived equation of the tangent at x1 comma y1. The meaning of at x1 comma y1 is the point is on the parabola. We worked out these derivations. See this one. So at, say this is the point P of x1 comma y1. So this means this must be a tangent. See, already we worked out this concept. So this is called tangent. At. So at x1 comma y1 means we can draw only one tangent. See here, from any point. That means the point should be outside. You already worked out the same theoretical concept. That means your practical geometry in your 10th standard itself you worked out. Two tangents can be drawn from any point outside to the circle. You already worked out in your practical geometry. The same concept. Here we are using two tangents can be drawn to the parabola. There you are using the circle. Here you are using the parabola. Y squared equal to 4x from any point outside. From any point means it should be outside. See this diagrammatic explanation. Already we worked out in your practical geometry in your lower standard. Instead of parabola, there you are using circle. See this one, standard equation. So now I am taking a point P of x1 comma y1. This must be a point. From this point I can draw one tangent here. From this point I can draw another tangent. So listen, I have considered this is the point P of x1 comma y1. This is the point P of x1 comma y1. In the same type you are using in 10th geometry, you are drawing a circle outside a point. We can draw two tangents. The same condition, same concept. See this one. This is vertex origin 0, 0. So this is the general equation. You are selecting the type 1 y squared equal to 4ax. Now the point is outside. Just now we derived the condition. What is the condition for the line y equal to mx plus c to be a tangent? See, y equal to mx plus a by m. This is the condition. Just we worked out. So this is also considered to be a tangent. I am already explained where m is the slope. See here, you are not using x1 comma y1. Before that, we are deriving the equation of the tangent, that is y1 equal to 2a of x plus x1. This is also the tangent. This is also the tangent. This is also the equation of the tangent. This is also equation of the tangent. What is the difference? If the point is on the parabola, that means equation of the tangent at x1 comma y1. We are using this word. See the difference. This is the equation of the tangent at x1 comma y1. We can use this one. Y1 equal to 2a x plus x1. Here, this point is unknown. This is also unknown. This is the point of contact. This is also the point of contact. So this point of contact is unknown. Therefore, we are selecting the equation of the tangent is y equal to mx plus a by m. When we are selecting this one, if the point is on the parabola, see like this diagram. Suppose we are selecting this one. This is the tangent, we know x1 comma y1. So then only we can select this one. This is the difference. See, the point is on the parabola. Here at, we can say the word at, equation of the tangent at x1 comma y1. Here we are not able to say equation of the tangent at. At means this point. Say we can say q and r. We can say q and r. Here q and r is the point of contact. This is unknown. Here say it is p. P is at x1 comma y1. This is the known value. If at x1 comma y1, we can use this one. So use this concept, learn this concept very clearly. This is the important place. Many students are doing the mistakes here. They are always using equation of the tangent means y1 equal to 2a of x plus 1. No need to memory. Recall the concept. At means the point should be on the parabola. Here the point p x1 comma y1 is outside. So we can select. So only we derived the theoretical concept. The condition for the line y equal to mx plus c is also a tangent to the parabola. We already worked out that condition. So equation of the tangent is y equal to mx plus a by m. See, when comparing this is also a tangent, this is also a tangent. Consider this tangent passing through the point x1 comma y1. That means this equation passing through p of x1 comma y1. This equation passing through p of x1 comma y1. Therefore, we can write this equation y1 equal to mx1 plus a by m. What is the difference between these two? Here we are having the equation, the variable y equal to mx plus a by. Here x and y are the variables. We are using the values of x and y is the variable. Here this equation passing through a particular point. So this point may be any number. So if you are substituting, we can get to y1 equal to mx1 plus a by m. Here x1 comma y1 must be a constant. Now, avoiding this m, I can multiply this equation with m. Then what will happen here? My1 equal to here m squared x1 plus a. I am multiplying this equation by m. So we can get my1. So m squared x1 plus a, converting into the same side. Now I can get m squared x1 minus my1 plus a equal to 0. Now what is the logic here? It is a quadratic equation in m. Already we discussed it. M is said to be a slope. So here m squared x1 minus my1 plus a equal to 0. Therefore, we can say it is a quadratic equation in m. By solving this equation, we can get two values of m, say m1 and m2. With the help of the two slopes, two tangents can be drawn. That is the logic. So, this is the equation of the tangent. We are selecting y equal to mx plus a by m. This tangent passing through the point p of x1 comma y1. Then this equation passing through the point p of x1 comma y1. Just to substitute. Here this variable x and y must be replaced by x1 comma y1. Then we can get the equation. By avoiding this m, I am multiplying this equation with m. I can say my1 equal to m squared x1 plus a. Converting the same side, we can get m squared x1 minus my1 plus a equal to 0. Now you have to say the explanation. It is a quadratic equation in m. By solving this equation, we can get two values of m. Two values of m. Say m1 and m2. Say m1 and m2. With the help of two slopes, two tangents can be drawn. That is the theoretical concept they require. See the heading. Two tangents can be drawn to the parabola y squared equal to 4ax from any point. See, from any point means the point should be outside. So we are able to draw the two tangents. Here PQ and PR must be two tangents. How we are able to draw? With the help of the two slopes. Where we are getting two slopes? By solving this equation, because it is a quadratic equation in M, by solving this equation, we can get two values of M, say M1 and M2. With the help of M1 and M2, we are able to draw two tangents. This is the theoretical concept. Dear students, with the same concept, you try yourself to the ellipse, to the hyperbola. That is your logic. Already we worked out the condition for the line y equal to mx plus c. So that I am already explaining the condition for the line y equal to mx plus c to be a tangent to the parabola, to be a tangent to the ellipse, to be a tangent to the hyperbola. Just we worked out. Here we are having one condition, one derivation. Two tangents can be drawn to the parabola y squared equal to 4ax from any point. The same type of derivation, the same type of condition is also applicable for an ellipse and also applicable for a hyperbola. So try your idea. So these are the theoretical concepts. You have to think about what are the theory importance. So if you are very confident to working out the theoretical concept, so any problems can be asked. You have to realize what is the meaning behind this one. So what is the question they are asking. So here why you are using this one. That is the important logic. Here at is not given. So the point is unknown. So at means the point should be on the parabola. So that we are selecting y equal to mx plus a by m. It is also the tangent we already discussed where m is said to be the slope. With the help of that only we are deriving. Then we are able to solve this equation. We can get two values of m. So that is M1, M2. With the help, we can draw two tangents. So dear students, try for an ellipse and also for the hyperbola. Thank you.